All right, so let's try to pick up where we left off yesterday. So if I give you something like this. Whoa. Not sure what just happened there. All right. So this is a big polynomial, right? If I ask you, what are all of the coefficients? What's a coefficient again? Number that's attached to an x. So, what are all the coefficients? 5, -4, -7. Is that it? What's 9? We call that a... What is happening right now? Let's try to stand on this side. 9, it would be considered a constant. Okay? And what's the difference between a coefficient and a constant? Constant doesn't have a letter. Okay? Now, the next question is, but how many terms does that have? The number of terms are basically always going to be separated by a plus or a minus. So this has 1, 2, 3. There are 4 terms. Does that make sense? Now, it actually doesn't even matter if it's x squared or y. If I said 8x squared y to the 3rd plus 4 x to the 8th y minus 3 x y to the 3rd plus 7. What is happening right now? There's a ghost. Maybe it's my ring is like tripping it off. I don't know. So in this one, what are the coefficients? 8, 4, -3. Yes? It has to be my ring. It's like pointing towards my ring. It has to be. Has to be my ring. All right, so 7, yes? How many terms are there?
6, 7.
Terms are going to be separated by pluses and minuses. There is 1, 2, 3, 4.
I don't know. I think I was counting like Y.
Does it matter if there's multiple x's and y's? Not at all. It just, if this is one term, everything that's connected by multiplication, that's one term. Okay? Easy enough? Okay. This homework assignment that I give you, I'm going to really ask that you show work on this. Because a lot of it's going to be pretty easy as far as how to get your answer and check it. But we're not necessarily just practicing multiplication. What I mean is this. One of the questions might be 9 times 52. I understand you have a calculator. I understand you could just type in 9 times 52 in your calculator. Right now, we're not practicing multiplication. We're not. We're using multiplication to practice our properties. We said yesterday, what is another way to think about 52? That's the same thing as 9 times 50 plus 2. It has to be my ring. Okay. So I want to see you break that apart. And then I also want to see, what is 9 times 50? Well, what's 9 times 5? 45 with a 0 on the end. Plus 9 times 2 is 18. And now you're just going to add. The answer is 468. Now, I get it. You could just type that in your calculator. That's not what we're practicing right now. Okay? I need you guys to understand, sometimes in life, in math, in football, in any walk of life. Sometimes it's not about the action you're doing. It's about the practice. When I used to coach football, I used to tell my kids all the time, there's two people working on a drill, okay? I'm on offense, you're on defense. Today I want to work on the defense, swim moves, whatever, right? Okay? If I, as an offensive guy, don't work hard on that drill, what's going to happen to him? He's not going to get the practice he needs, right? I have to be a good teammate, and it's not about me right now, right? I have to work hard. I have to do what I'm supposed to do and try to block him so that he can practice what he needs to practice, and then vice versa. It's, to me, the same idea with this. We're not really worried about the multiplication right now. What are we really practicing here? It's not about the multiplication at this point in time. It's about the distributive property. We're practicing the distributive property. This is just one use of it. Does that make sense? And then the next problem, you're going to get something that looks like, it's going to look like this. It's going to say something like 53 plus 28 plus 17 plus 12. Now, it's all addition. We're not really working on our addition right now. I want to try to find, is there a way we can regroup this to make our life easier? Which numbers would be the easy ones to add together? So what we want to do is use the commutative property, rewrite this as 53 plus, what do I really want to add to 53? 17 and then I want to do 28 with the 12, right? These two add up to what? 70. Plus these two, careful, 40. Then add them together to be 110. Could I have just added them from here and said 53 plus 28, well, let's just add those together. That'd be 11, carry the 1, 7, 81, and then add the 17. That'd be 8, 9, great. Now add the 12, and 0, carry the 1. Sure, I get the same answer, don't I? What are we practicing right now? Are we practicing addition? No, what are we practicing right now? The properties, the commutative property, the distributive property. So please make sure you are showing your work with those. Does that make sense? All right, everybody take a look at page 49. 49. Grab one out of there. Cabinet in front of you. Just put it back before you walk out of the room. It's right by your eyes. There you go. All right, page 49. When you do a question like number 2, that said, well, let's do number 3. 16 plus 2.5 plus 4 plus 1.5. This isn't about addition. This is about regrouping, using properties. Which numbers would be the easiest ones to add together? What do I really want to add with 16? Okay, so 16 plus 4 is 20. Plus, I would want to do 2.5 plus 1.5. What's 2.5 plus 1.5? I have $2.50. You have $1.50. What is going on? I don't know. So what's 2.5 plus 1.5? 4. The answer is 24. How much of that do I want to see on your homework tonight? All of it. Pretty much all of it. At a minimum, I want to see this because that shows me basically we're using the commutative property to flip-flop those, right? And then we're regrouping. We're finding a way to get those to group together so it's easier. When you do a question like number 8, where it says 14 times 1,002, what's an easy way to do that? What's another way to think about 1,002? 1,000 plus 2. Okay. Really, my hand was behind my back. What is happening right now? Who's got an extra mouse? Who's messing with me? Okay. What's 14 times 1,000? 14,000, right? Plus, what's 2 times 14? 28. What's 14,000 plus 28? Well, it's 14,000 and 28. Again, please show your work. This is about being able to expand this into a different distributive property and go from there. Fair enough? All right, let's see how quick you guys can do these. I want to rapid fire answers. If you look at we're on page 49, I want you to look at number 14. What's 6x plus 10x? 16x. Number 15, 35x minus 15x. 20x. 16, negative 3a plus 9a. What's negative 3 plus 9? Negative 3 plus 9. 6a. You said negative 6a. I heard the 6. I wanted you to say it again because you said it real quiet. Number 17. What's negative 8r minus r? You have negative 8r's minus another r. What number is attached to that r right now? 1. What's negative 8 minus 1? Negative 9r. Yes? How about number 18? What's 17x squared plus x? 17x squared plus x. What's the answer here? What? Where are you getting 290? Oh, the 17 is not squared.
18x squared.
The answer to this is 17x squared plus x. Why? Why did I not actually add that to 18? Why? Why can't I? Are those like terms? No. If it said 17x squared plus x squared, yes, that would be 18x squared. But the only way we can add them is if they're actually like terms, right? Does that make sense? Don't just assume that you're going to add or subtract every single one. If this is the question, this is what you're going to write for an answer because no, they're not like terms. You can't actually add them. Are you good? Okay. What I would like you to do right now, everybody take out a sheet of paper. You're going to start on 26. Yeah, no.